Hello! Let's do some exciting matrix summations or sums. Let's add up two matrices. What do I mean by a matrix? Well, a matrix is a collection of numbers. It's something like this box here. So this A is a matrix. This A11, A12, A13, AN3, all these are numbers. Okay, so these are called coefficients of the matrix or entries of the matrix. This is an entry or a coefficient of the matrix. Okay, and the matrix has m rows. That's the first row, second row, third row, up to row m, and n columns. First column, second column, third column, nth column. Okay, so the matrix is just a collection of mn numbers, m rows and n columns. First the number of rows, second the number of columns. And here the same thing. So this is the coefficient 1, 3 because it's in the first row and third column. And this is the coefficient 2, 1 because that's in the second row and the first column of the matrix. So this matrix here has dimensions m by n. Rows, columns. How many rows I have, how many columns I have. Okay? So you can add only matrices of the same dimensions, okay? For instance, if matrix A has dimensions 3 and 4, and B is also a 3 by 4 matrix, okay? So the first ones, the 3 is the number of rows, and the 4 is the number of columns. So that's A is a matrix with 3 rows and 4 columns, and also is B. Therefore, you can add up the two matrices. And what you get is, again, a matrix with 3 rows and 4 columns. So this is the dimensions of the sum of the matrices. You add two matrices, you find another matrix with the same dimensions. How about if I add this and this? This matrix A has 7 rows and 6 columns. B has 8 rows and 6 columns. This 8 is a different number than 7. So you cannot add that, okay? So you cross. This is all wrong. You cannot do, they are not compatible. If one of the two numbers is not equal to the other, you cannot add. There's no addition. So the answer in the exam is there's no sum because the dimensions are incompatible, okay? Let's see some examples. This matrix here has 2 rows and 3 columns, so it's a 2 by 3 matrix. This matrix here, again, has 2 rows and 3 columns, a 2 by 3 matrix. How you add these two matrices? Well, first you find something which is 2 by 3 as well, again, right? And now you go coefficient by coefficient. 1 plus 7 is 8. 2 plus 8 used to be 10. 3 and 9, if I'm not mistaken, is 12. You check if I'm doing right, huh? 4 and 10. 14, 5 and 11, 16, 6 and 12, 18. So this matrix here is the sum of these two matrices here. How about this other example? This has 2 rows and a single column, so it's a 2 by 1 matrix. This, again, has 2 rows and 1 column. So 2 plus negative 4, 3 plus negative 1, okay, so that's how you add. You add these numbers, you find 2 plus negative 4 is minus 2, and 3 plus negative 1 is 2. In general, that's the formula of the sum of matrices. The ijth coefficient, or the ijth entry of the sum matrix, is the ijth coefficients of matrix A plus the ijth coefficients of matrix B. Okay, so this is a number and this is a number. So this is something I know how to do, to add numbers. And you have always that A plus B is B plus A. Because the numbers, you can change the order. They are commutative, so the sum of matrices is commutative. You can also have another property. If you add A, B, and then C, this is the same as adding A with B plus C, okay? So you have this associative property as well for every 3 matrices, assuming, of course, that A, B, and C have all the same dimensions. What about if you want to subtract two matrices of the same dimensions? Suppose A and B have the exact same dimensions. What's A minus B? Aha, that's tricky. And for that, I have reserved a very special explanation. Come with me. Come. Aha, let's see A minus B. To do that, we're going to have to learn how to multiply a number by a matrix. And a number sometimes in mathematics they call a scalar, but the scalar is just a number, okay? A fancy word for a number. If you have a number and you multiply by a matrix, what you find is a matrix. And the ijth coefficient of this matrix is just your number A times the ij coefficient of the original matrix B. Let's work out examples. 2 times this matrix, 1, 2, 3, 4. So the 2 gets inside. When the 2 gets inside, the 2 multiplies everybody. Okay? So that's going to be 2, 4, 6, 8. This matrix is a 2 by 2 matrix. This matrix is a 2 by 2 matrix. I'm multiplying this matrix here by the scalar 2. So the 2 goes inside and multiplies everybody, and you find that. Okay, now I would have 4 times this matrix here. This matrix has just 1 row and 4 columns. It's a 1 by 4 matrix. So the result here will also be 1 by 4. And now the 4 gets inside here, 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 and here. So 4 times 1 is 4. 4 times 2 is 8. 4 times the square root of 2. 4 square root of 2. 4 times 0, 0. So that is the result of multiplying 4 by this matrix here. Okay? Now, what about if I have a negative 1 here? What happens? Negative 1 times that, so the negative 1 goes inside and multiply everybody inside. So negative 1 times 2, negative 1 times negative 4, negative times a negative is a positive. Negative 1 times 3. And negative 1 times 0 is 0. Okay? So this is a 2 by 2 matrix. And this is also a 2 by 2 matrix. So in general, minus B, minus a matrix B, is just shorthand for negative 1 times the matrix B. And we know how to calculate negative 1 times B. Here's an example. You just multiply every coefficient by negative 1. Okay? So, now fulfilling my promise. What's A minus B? A minus B, it's going to be A plus minus 1 times B. That's how we think about the subtraction of matrices. There's not the direct way to subtract. The direct way is to think this. Okay? So if I have this times that, I would have to pick up this matrix plus minus 1 times this matrix here. But in practice, you can do directly as the easy way. So 2 minus 1 is 1. 3 minus 2 is 1. 4 minus 0 is 4. 5 minus minus 1. So what happens if I have a minus minus? So it's 5 plus 1, 6. 5 minus minus 3, it's 5 plus 3, which is 8. And, oops, but that's not a 5, that's a 6. Bad teacher, bad. 6 minus minus 3, it's 6 plus 3, which is 9. 7 minus 1 is 6. So these matrices are 2 rows and 3 columns. This has 2 rows and 3 columns. This has 2 rows and 3 columns. Okay? So always when you subtract, you have like this. So if you have a matrix A minus B, that is minus 1 times the other way around, B minus A. So you can operate with the matrices like that, and when you have a number A times a number B times a matrix C, that is the same thing as AB times the matrix C. Or you could have B, AC. All these properties are satisfied by matrices. Multiplication of scalars by matrices is really simple. And we think of the subtraction, this is important because we think of the subtraction this way here. This is what it means to have the subtraction of two matrices, okay? Okay, I hope you have a lot of fun. I did at least. Thank you very much. See you next time. Bye-bye.